Hey everyone, welcome to our solutions video for test number 47 in our series for selective prep mathematics. As usual, we'll just get started with an overview. I think we've only got one topic in our overview today, and that is volume conversions, which we also went through last week. So if you were here with us last week, feel free to skip over and get straight to the solutions. Otherwise, bear with me. So it's sometimes quite a struggle to try and remember different volume conversions, and that's the problem with a lot of things related to rote learning or just memorizing things for the sake of memorizing. So there's no point in trying to rote learn things because in the end we're going to forget them if we don't understand it. So it's important that we understand what the fundamental logic is, and then everything else kind of follows along from there. So let's get into the fundamentals. So we know that a centimeter cubed, so we're looking at volume. So 1 centimeter cubed is 1 centimeter by 1 centimeter by 1 centimeter. Okay, in the same way, 8 centimeters cubed is going to be 2 centimeters by 2 by 2. Okay, and 16 is, not 16, 27 is going to be 3 by 3 by 3. Okay, now, when we have these units, and we want to transfer it to liters or milliliters, okay, what we need to keep in mind is that 1 centimeter cubed equals 1 milliliter. Okay, so those are our fundamental units. Now, the rest kind of follows. Now, when we're trying to convert things into meters cubed, okay, 1 meter cubed equals 1 meter times 1 meter times 1 meter. We know a meter is 100 centimeters, so it's just going to be 100 centimeters multiplied by itself 3 times. Okay, so 1 meter cubed is 1 million centimeters cubed. Now, 1 liter equals 1,000 mils. Okay, so if we're trying to convert centimeters cubed into liters, we should know that a liter is 1,000 milliliters, and 1,000 milliliters is the same as 1,000 centimeters cubed. Okay, so we should know that 1 liter equals 1,000 centimeters cubed. A liter in terms of meters cubed, okay, so 1 meter cubed is 1 million centimeters cubed. So if a liter is 1,000 centimeters cubed, it's going to be 1,000th of a meter cubed. 1 over 1,000 meters cubed. Okay, so this is a type of logic that follows, and you guys should be able to do it even though if it's not 1, or even though it's like 8 or 0.1. Okay, the general logic follows through. Now we're going to use this, so we're going to apply it to our question straight away. So we have area here. So this garden here we see on the right has an area of 400 meters squared. The vegetable patch, which is this, and the orchid has areas of 133.6 and 46.2 respectively. Okay, so what's the total area of the lawn and pond? So that's everything else. So that's everything here. I wonder why my pen's gone so thin. Anyhow, so these added together are going to be 179.8 meters squared. So let's just say that's basically 180. Now, if we have 400 meters squared minus 180, that's going to give us 220. So we're just going to add the 0.2 that we didn't minus. So it's 220.2. Question 2, sorry. The area of the lawn is 45% of the garden. So it's just 400 and then 45% of that. Now, let's just take what 10% is. So 10% is going to be 40. Okay, 10% is 40, 5% should be 20, okay, and so 40% is going to be 40, actually let's do 50%, 50% minus 5, that's going to be easier. So 50% is going to be 200, minus 20, so it's going to be 45% is going to be 180. Finally, we have the pond in the garden. It's got an area of 130. What percentage of the garden is taken up by the pond? Okay, so when we do percentages, okay, we should always do this as a fraction of the full area times 100. So it should be 130 divided by 400 times 100%. Okay, the zeros cancel out here, so you can just do 13 divided by 40. Now, when we do that, what we're going to get is, so if we put 13, if we're dividing 13 by 40, okay, we're going to get, okay, this is going to be a decimal, so I'm going to put my .000s at the end. So how many times does 40 go into 13? None. 13 is too small. So we're going to carry the 13 over here, Okay, it comes 130. How many times is 40? So it's going to be 0 point something. So 40 goes into 130 3 times, leaves over 10. Okay, which it goes into 2 times, leaves over 20, which it goes into, it goes into 200 5 times. So 13 over 40 is the same as 0.325, but we've got to multiply it by 100%. Should give you 32.5%. All right, simultaneous. So this, I call this simultaneous because there's a special way of doing this. So we have 30 coins. There's 5 cent, 10 cent, 20 cent coins. So for our 5 cent coins, so we've got 20, 10, and 5. So for our 5 cent coins, we have 3 times as much as we do 20 cent coins. So let's say we have X number of 20 cent coins, 3X number of 5 cent coins, and we have double the number of 10 cent coins as 20. So we're going to have 2X. Okay, so how many X's is that altogether? So that's 20X, that's 20X, that's 15X. Okay, now add that all up, should give you 55X. So there's 55X altogether. Okay, we have 55X, and so this adds up to, so this is the number of coins, and then this is the value of each coin. When we multiply the number of coins by the value of each coin, we should get $2.75. Okay, $2.75. So 55X equals $2.75, which means that X is equal to 5. Okay, so we have 5 20-cent coins, we have 10 10-cent coins, and we have 15 5-cent coins. Okay, so how much is the value of the sum of 5 cents of the 5-cent coins and the 20-cent coins? Okay, so it should be 20 times 5, and then plus 5 times 15. So it should give you 100 plus 75, and $1.75 is your answer. Question 5. So this is a fractions question. There's 420 students. 3/7 are boys. Okay, so what's 1/7? Okay, 1/7 is going to be 60 times 3. So 3/7 is going to be 180. Now, 4/9 of these boys attend a drama class. So what's 1/9? 1/9 is 20 times 4. So 1/9 should be 80. So 80 boys attended a drama class. 6 is a volume question. So we have the working out down here. So the diagram shows a cube. It's got side length 30. And then we have a little cube taken out with side length 5. So instead of giving it the answer to us in centimeters cubed, they've given it to us in meters cubed. So we're going to convert everything to meters cubed first. So this is 0.3 meters cubed. Okay, so 1 meter equals 100 centimeters, not 1,000. So be careful of that. And 5 centimeters is 0.05. Okay, so we can see the working out down here. 0.3 times 0.3 times 0.3, which is the big cube, minus 0.05 cubed, which is the little cube. So that should give us the volume of what's left over. Okay, and that is going to be E. Question 7. The surface area is actually going to be the same as it would be if it was a full cube. Why? Because if you look at it from this side here, from this left side here, you're still going to see a square. So you're going to see this little cutout here, but then you're going to see this little square, and you're going to see a full square like that. If you look at it from the other side, you're going to get the same thing. Okay, whichever side you look at it from, you're going to get the same square view, I guess. Okay, if you don't believe it, okay, just try and add up all these little bits first, and then add up the little bits after. Either way, you're going to get the same answer, but this is a lot quicker. Okay, so whichever view you look at it from, you're going to get the same 30 by 30 square. Okay, and then 30 by 30, which is the area of one square, times 6, because we have 6 squares, equals 5,400 centimeters squared. So part B is your answer. Question 8. So I'm not entirely sure what the point of giving you this wheel was, because you could just figure out the code from this here. So they've just moved 4 letters along the alphabet. Okay, I found that a lot easier than using the wheel. So I just used that. If you want to know what they've done with the wheel, so they said that Melissa used the code wheel that's similar to this, but a little bit different. So she rotated a little bit in terms of the outer ring. So what she's done is, we're looking at S. Sorry, where's S? We're looking at S, and it needs to align with, actually, I think we're looking at the S on the inside. We look at the S, and we need to align it with V. So what's happened is that Melissa used, but with the outer ring of letters rotated. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it was rotated 11 clockwise. Or if you're looking at the outer circle and you wanted to match up with the inner circle, then you could have rotated the inner circle 11 clockwise as well. Either way it works. So, or you could have rotated it this way, anti-clockwise. Either way, it's 11. Okay, but I just did each letter is just 4 letters along the alphabet. So S becomes V, K, N, or 3 letters, however you want to count it. So S, T, U, V. So you could go 1, 2, 3, or 1, 2, 3, 4. It doesn't matter, however you want to count it. K, L, M, N. Okay, again, it's across 3 to 4 letters, however you want to count it. I think it's actually 3. So 1, 2, 3. Okay, and if you want to check for everything else, it's the same pattern. So what you should have gotten straight away, so she used the code wheel to decode this, okay, which must mean that everything she's gotten is 4 letters ahead of what the actual word was. Okay, so this would have been D, E, F, G, so D, okay, oh, we look and there's only one D anyway. Okay, so it has to be part C. It's not B. If you thought it was B, it's not B, because this is what we got, okay, using this pattern, which means that we need to go 4 backwards. So she's changed it so it's 4 letters ahead, which means we need to go 4 backwards. Okay, if you've got a watch and it's 10 minutes faster and you want to know what the actual time is, you got to go back 10 minutes, right? Okay, so it's the same pattern there. Now, prisms, okay, with our cubic prisms, or our nets, okay, this is what we call a net when it's all raffled apart. It's not a full cube yet. What we generally want is a straight row of 4 and then 2 blocks on either side. Okay, we want a straight row and then 2 blocks on either side. So we got this. Okay, this doesn't work. This doesn't work. This doesn't work. This should work. This doesn't work. This doesn't work. So we got 1, 2, 3, and then this does work. It's a little bit special because basically, if you fold this up, okay, you're gonna get like this kind of shape here, like that. Okay, this is just gonna fold in and become that far side square. This here is gonna fold in and become the square on the side. And then once you fold this in like this, okay, or that way, it's just gonna close up. Okay, so D happens to work as well. So A, B, D, and H are our answers, so part C. Question 10, I think it's our second last question. We have a class of 40, 25 like maths, 29 like English, and there are 6 students who don't like either. So if we add that up, that's actually more than 40, which means that one student or more than one student can like both. Okay, and they'll count as 1 in both categories. So there's 6 who don't like either, which means that only 34 liked English or math, or both. So we've got 34 to work with, 6 are kind of outliers. So we've got a Venn diagram. This is our Venn diagram. We've got 6 out here because they don't want to be English or maths. We have English, maths, and so 25 plus 29. Okay, how many is that? How many are we actually going over? So that's going to be 54 in total, which means that 34, we've actually got 20 going over. Okay, now, it's not that we have 20 students doing both, it's that out of both of these, there's 20 overlaps, which means that there must be 10 students as overlaps, or 10 students overlapping, okay, because 10 students, okay, are going to count as 1 each in 2 categories. So if we have 10 students counting as 1 each in two categories, they're going to add up to 20 if we're not careful, okay, and we don't indicate it as an overlapper. So we have 10 in here, and we should have 15 and 19. So we should have 15 and 19, 10 in the middle. Does that add up? No, it does not. Oh, yes, it does. Sorry, it should add up to 34. So it does add up. So we have 15, 19, and then 10 in the middle. That should say 10, I believe, not 20. So, and then we have 6 left over because there's a class of 40. So the question might be wrong, but you guys get the general principle as to how we got 10 in the middle. okay, it might have been 50, which is why I only got 10. So this might have been 50, not 40. But if it was, then you know how to get whatever's overlapping. Okay, so take the difference, divide it by 2, because they're going into 2 categories, which means that even if there's only one of them, they're going to count as 2, because each subject counts them as 1 each. Now our last problem, so we have KLM and LM. Okay, each letter represents a different number. L is 7, so we have K, 7, M, N, and then we have another M here, times by N, and then we have N, 7, M. Now, without M's, let's calculate what the M is going to be first. Without M's, M could be 1. Okay, M could be 1, it could be 5. So 5 times 5 equals 5. It could be 6. So 6 times 6 is going to be 36. We're going to have 6 left over here, and then we're going to carry the 10s up to here. So if it's 1 times 1, we're going to get M equals 1 down here, and it carries up with nothing. So 1 times 7 will also be 7. But 1 times K, okay, would be N. So 1 times K would be K. So it can't be 1, because 1 times K should give us K, not N. Now 5 times 5. So we have 5 times 5 gives us 5. Carry the 2 over. 5 times 7 is 35. Plus 2 should give us 37. And then carry 3 up here. So it works. So this second row works with 5. Now let's try it with 6. So 6 times 6 gives you 6. Okay, carry 3 over. 6 times 7 is 42. Plus 3, 45. So this second row doesn't work for 6, which must mean M has to be 5, because it's our only option. So it's K7, 5 times 5 over N7, 5. So we figured that out. So 5, 5, 25, carry the 2 over. 5 times 7, 35, plus 2 becomes 37. Carry the 3 over. 5 times something, okay, equals N. So 5 times anything is going to be like a 0. It's going to end with a 0, or it's going to end with a 0 or a 5, right? So if you add 3 to that, it means it has to end in a 3 or a 8. So N has to be a 3 or a 8. Do we have a 3 in our options? No, we don't. Do we have an 8? Yes, we do. So it has to be D, okay? All right, very good job, everyone. I think that's the end of our questions. Our key points was the volume conversions. Just remember that if you remember the fundamentals, and then you don't need to rote learn anything, and it's not like a really boring process and a really confusing process then, because now you get it, you can formulate it on your own without having to actually rote learn it, okay, and stress out before an exam or a test, okay? So that's it for today's video. I'll see you in the next video, guys. Enjoy the rest of your day.